Okay, welcome back. And today what we're going to do is we are going to work on an example of using the rational zeros theorem to factor a polynomial. And this polynomial, it's going to be a fourth degree polynomial. So here's what I have. So we have f of x is equal to 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. And so part A says list out all the possible rational zeros. So what I'm going to do is I'm going to list all of the factors of a sub 0. Those are going to be all my possible p values. Okay, so if I look at p, so my possible values is going to be plus or minus 1 and plus or minus 2. Why plus or minus? Because it is possible that I could have negative 1 times negative 2, which would give me positive 2, plus 1 plus 2 will give me negative 2. So these could be plus or minus, okay? Now what about the q? So here's 6, right? So this is my a sub n, right? So now all my q values are going to be the factors of 6. So again, that's going to be plus or minus 1, plus or minus 2, and plus or minus 3, and plus or minus 6, right? So those are all the different factors of 6. Now what I'm going to do is to find all of the possible rational roots, I'm going to take each one of these and divide them by each one of these to get all my p divided by q's. So if I want, p over q then is going to be in the set. So now I'm going to take 1 divided by 1, so that'll give me plus or minus 1, and then 2 divided by 1 is going to be plus or minus 2. And now I'm going to go to the next one. 1 divided by 2 is going to be plus or minus 1/2. 2 divided by 2, well that's going to be 1. I've already got 1, so I don't have to do that again. Okay, so any duplicates we just skip. Okay, now I'm done with the 2. Now I'm going to go here. So 1 divided by 3 is 1/3, so I'm going to get plus or minus 1/3. And then 2 divided by 3 is going to give me 2/3, so I get plus or minus 2/3. And then finally we're going to go to the 6. So 1 divided by 6 is 1/6. And then 2 divided by 6 is the same as 1/3, so I've already got 1/3, so I'm done. So I went through and cycled through all of them. And so that's my possible rational root. So what this is again saying is that these are my possible rational roots that I'm going to try. Now, it doesn't guarantee that any of them will work, but this will be a good starting spot. If something's going to work, or excuse me, let me rephrase that. These are a good starting spot to start with. Okay, now I could go through all of them and find out that none of them work, and then I'll have to try something else. Okay, so, but again, in this class called Algebra, normally one of them is going to work. Okay, but again, you won't know unless you exhaust all of them. Usually what happens is you find 1 or 2, and that usually gets the polynomial down to a quadratic, where we can then go ahead and use other tools like factoring and things like that. Okay, so that's part A. So this is the answer for part A. Now what we're going to do is we're going to use these rational zeros to factor this polynomial. So let's start with plus or minus 1. Those are easy, right? So let's do plus or minus 1. Okay, now, one interesting thing to do to check for 1 plus or minus 1. There's an easy shortcut. So you know if you plug in 1, all of these x values become 1. And all you end up with are the coefficients. So the shortcut is if you add up all of the coefficients and the sum of the coefficients add up to 0, then 1 is a 0 of the polynomial. Okay, so let's do that. So if we do 6 plus 7 is 13, minus 12 is 1, minus 3 is minus 2, plus 2 is 0. So they add up to 0. So 1 is a 0. So now we still have to factor it, right? So we still have to do synthetic division. So let's do the synthetic division because we still, now that we know it's a 0, but we still need to know the quotient. So it's going to be 1, so it's going to be k minus 1, or excuse me, x minus 1. So we want to then put the coefficients. So we're going to put 6, make sure we don't need any place values. 6, 7, negative 12, negative 3, and 2. And so I'm going to put my line. Okay, so now we're going to do the synthetic division. So that's going to be 6, 6, 13, 13, 1, 1, negative 2, negative 2, 0. Okay, and so here's our remainder. And so that means, based on these coefficients here, and based on our 0, that means one factor is going to be x minus 1. And the other part of it is going to be what? It's going to be 6x to the third, right? 6x to the third plus 13x squared plus x minus 2. Okay, so now remember, from the factor theorem, okay, so we got a 0. So we know x minus 1 is the factor, since it became a 0, 1 is a 0, so we know that this has to be a linear factor. And then the quotient is given to us by this. So now we have to just factor this thing. And again, it's a cubic, okay? And it looks like there's nothing factorable, so we can't factor by grouping here. But we can go ahead and try another. So let's try 1 again. See, here's the thing, it might be a repeated 0, okay, or what we're going to call later a repeated root. So it might work again. So let's try 1 again. So just because it worked once doesn't mean it won't work again. It may work again. Now, if it doesn't work, then we know we're done, okay? Because if it doesn't work for 1, it's not going to work for any of them. Okay, so let's add up the coefficients. So we got 6, 13 is 19, plus 1 is 20. So obviously that's not going to add up to 0, so that didn't work. Okay, let's try negative 1. So we know we're done with this. Okay, so I'm sorry. We just did positive 1. Let's do negative 1. Okay, negative 1 might work. Well, how do we test for negative 1? Here's another shortcut that works for negative 1. Well, if we go to negative 1, the ones that are odd will change sign. So here's what you do. You change the sign of the coefficients for the odd-powered terms, and then you add those coefficients up, or all the coefficients up, and if those coefficients add up to 0, then negative 1 is a 0. If they don't, then it's not. So this is odd, so we're going to make this negative 6. Okay, so we'll have negative 6. This is even, so we're still going to get 13. This is odd, so we're going to get negative 1. And then this constant stays the same, so it's negative 2. So now we add. So negative 6 plus 13 is going to be positive 7. Minus 1 is 6. Minus 2 is 4. So it didn't work. So that means we're done with plus or minus 1. Okay. So now plus or minus is done. We're not going to deal with that anymore. So let's go on to plus or minus 2. So let's use 2. Now there's no shortcuts for this one, so we'll just have to try it. So in this case, we're just going to try 2. Let's do positive 2. And so now we're going to list the coefficients. 6, 13, 1, and minus 2. And so now we're going to drop down, we're going to start the process. So what do we got? We got 6, down 12, 25, 50, 51. Well, this obviously isn't going to work, right? It's obviously not going to give us 0 here because it keeps getting bigger. Okay, so let's try negative 1 or negative 2. So positive 2 didn't work, so positive 2 is out. So let's try negative 2. Okay, so let's do it again. So we'll do 6, negative 2. This gives us a negative 12. That gives us 1. This gives us a negative 2. That gives us a negative 1. Ooh, look at that worked. Okay, so now negative 2 worked. So now we can rewrite this as x minus 1 times x plus 2, because this is negative, so it's going to be x minus negative 2. So x plus 2. And now, what's left over? Well, now it's going to decrease by 1 more degree, so it's going to be 6x squared plus x minus 1. And so now we get a quadratic. Now, quadratic, we can factor by different tools. We can do the AC method. So let's do that. So no, we don't need synthetic division anymore, and we don't need this anymore because now we can use other tools. So what are factors of negative 6 that will add up to a positive 1? Well, that's going to be 3 and negative 2. So guess what? Now we're finished, because we got f of x is equal to x minus 1, x plus 2, and we're going to get 6x, oh, let's do it over here. We got 6x squared plus 3x minus 2x minus 1. And so this is going to factor, right? We're going to factor by grouping. So this is going to give us a 3x times what? 2x plus 1 minus 2x plus 1. And so this is going to give us 3x minus 1 times 2x plus 1. And we're done. So this is 3x minus 1, and this is 2x plus 1. And this is our final answer. So that's it. So that's how we can use the possible rational, the rational zeros theorem to find rational zeros that we can try using synthetic division. And then once we get it down to a quadratic, then we've got other tools in our toolbox and we can use those. Okay, that's it. Have a great day.